Hello everyone, hopefully by now you've had some time to work on the chapter 8 practice test. If you're struggling with it, I have made a video for everybody to help you out. Alright, let's begin. So the first question, graph the function g. So here's what I would do. So first, we would begin with graphing this first one right here, the f of x, right? So to do that, we first want to identify what the vertex is. And here, our vertex is 2, comma, negative 3 for this one. So let's write that up here. 2, comma, negative 3. That's going to be our vertex. Okay. That's the vertex for f of x. Right? So let's go ahead and label that 2, comma, negative 3. So we're going to go 2 to the right and 3 down. 1, 2, 3. So it'll be right there. Oh. Alright. And now we're going to find a couple other points. So now let's figure out maybe the y-intercept, right? Because that'll be the simplest one to find. So we can plug in 0. And when you plug in 0, you have 0 minus 2, which is negative 2. Negative 2 squared is 4. And then 4 minus 3 is positive 1. So our second point is 0, comma 1. And that's going to be right here. And since this is our vertex, we know that our axis of symmetry is going to be right here. Let's see if I can draw this. Alright, so that'll be axis of symmetry. And since this is 2 to the left, we're going to have the same point 2 to the right. Okay. So there's our f of x, the graph for f of x. Let me go ahead and turn this into a line. It's a little difficult on here. Alright, so that's our first graph. And our second graph says g of x is equal to f x plus 3. And let's take a look at this real quick. So here, we're moving 2 to the right, right? 1, 2. And now, it's asking us to move 3 to the right or left. Well, remember that it's x, let me write this down here, x minus negative 3. Let me do this a little bit better. X minus negative 3. Right? So that means we're shifting this entire graph 3 to the left now. So what we're going to do is, let's change our color real quick. So we're going to take each point and shift it 3 to the left. 1, 2, 3. And since this is our vertex, that means this is our new vertex. So we're going to take this y-intercept, shift it 3 to the left. 1, 2, 3. Then we're going to take this point, shift it 3 to the left. 1, 2, 3. And now, let's connect this. And we're going to connect this one as well. Alright, and that's what it would look like if we had g of x. So the red one is g of x. Oh, this is a little tough to write. And the purple one is the graph of f of x. Alright, so the very first step is to plot the vertex of your original graph. And then find the y-intercept or any point that's useful to use. And third, you use this axis of symmetry to figure out how to use the point the point that you got, and how you can reflect it back. So in this case, we found the y-intercept, and because we knew the axis of symmetry was right here, we could reflect it onto the other side. And by doing this, we do less work. We only had to find 2 points in the end. All right, let's try the next one. Graph the function of g. So for this one, see if you can try to guess by yourself first. We need to find the vertex again, and this is because we already have it in vertex form, so that makes it very easy to do. So let's go ahead, plug in 0 for x. Oh wait, no, that's for the y-intercept, my bad. So our vertex in this case is 3, -2. Let's write this down. 3, -2. So let's go ahead and plot that. So 3 to the right, 1, 2, 3, and down 2. So right here. And now we need to find a couple other points. However, if you try plugging in 0, you'll notice that it's not on the graph. It's way, way below. So we're going to try another point. Let's try a point that's right next to the vertex. Let's try 4. Right? This would be 4 right here. So x equals 4. So try plugging in by yourself. So I'm going to plug in the points that we already have so far. 3 and -2. I'm going to plug in 4 now. So if we plug in 4, f of x is equal to -3, 4 minus 3 squared minus, oh, I'm running out of space here, minus 2, right? When we do that, 4 minus 3 is 1, right? 4 minus 3 is 1, squared is 1, so we have -3 to the power, -3 times 1 minus 2, and remember, the rule of PEMDAS, we need to multiply before we add and subtract, right? So -3 times 1 is -3 minus 2 is equal to -5. So we're going to go ahead and write -5 in here. And let's plot this in the other point that we have. So 1, 2, 3, 4, and then down 5. 1, 2, 3, 4, 5. So the next point will be right here. Oh, let me fix that. All right. And since we know that this is our axis of symmetry, since this is our vertex, we know that the new point that we've calculated for -5, which is right here, is going to have to reflect across the axis of symmetry. So we can just put another one right here. Since this is 1 to the right, we're going to put 1 to the left. And now we can create our graph. However, we could find another point. So let's go ahead and try plugging in 5. If you plug in 5 for x, you get 5 minus 3. 5 minus 3 is 2. 2 squared is 4. 4 times -3 is -12. -12 minus 2 is -14. Right? So we can go ahead and plug that in as well. 5 and go all the way down to -14. And once again, since we have this axis of symmetry right here, we can reflect it right across. Since this is 2 to the right, we can make 1 2 to the left. Then we can go ahead and create our graph. Let me try to do this a little bit better. It's a little bit messy because I'm doing this with my finger. Alright, so that is one of our graphs. And now we can create our second graph. And this +2 is outside f of x. Because it's outside, that means we're shifting the graph vertically, right? So we're moving this whole entire graph up by 2 points now. So every single point on here is going to be shifted up by 2. So we're going to move this point over here up 2. So 1, 2. So our new point is going to be right here. And then we're going to move this point up 2 as well. So the new point's right here. This one's also going to go up 2. This one will also go up 2. This point will also go up 2. And now we can draw a graph for this line too. As you can see, this new graph also shares this line of symmetry, the same axis of symmetry here. It's just shifted up by 2 points. And remember to always use the axis of symmetry to find what the point would be if you reflect it across, so that you don't have to do more work. If you use the axis of symmetry, you can find your second point without extra work. Alright, let's try the next one. Find the zeros of the function. Let's do a different color maybe. Let's try this one. Alright, so we're going to change f of x to 0. And that because that is how you find the zeros of the function. We're going to create our table. So our first equation is x plus 3 is equal to 0. And our second one is x minus 5 is equal to 0. If we subtract 3 on both sides, we get x is equal to negative 3. And then add 5 to both sides, so we can isolate the variable, and you're left with x equals 5. So that would be our two zeros of the function. And now, number 4 asks us to choose a quadratic function in standard form whose graph satisfies the given conditions. The condition is that the x-intercepts have to be equal to negative 1 and 3. Notice that it doesn't specify what the a value is. So in this case, it just has to equal negative 1 and 3. That's it. So let's see. Let's take a look at this one. This one has an x-intercept of about 0.2 possibly, 0.2 and 5.4 or 5.8 I mean. Let's see. Let's take a look at this one. This has an x-intercept of negative 2 and 4. And remember that when we're talking about the x-intercepts, we're talking about this right here, the x-axis. The x-intercept is where it crosses this x-axis. So we don't care about when it crosses the y-intercept in this case. So this one definitely will not work because this is negative 2 and 4. This one here might be the correct answer, right? Negative 1, 3. Let's write that down over here. X equals negative 1, x equals 3. Well, this one also does look kind of correct, right? But if you take a closer look, this one is x equals negative 3 and x equals positive 1. And the question asks us to have a negative 1 and a 3, and this one fits it. So our answer is going to be D. All right, let's do the last one. Okay, so number 5 asks us to match the description below with the graph. All right, and real quick, this should say y is greater than or equal to 4. Let me write that down here. Or equal to 4. Okay, so for this one, the vertex has to be negative 2, 4. The axis of symmetry has to be x equals -2, right? If the vertex is -2, 4, this -2, the x value, is going to be the axis of symmetry. And the domain is going to be all real numbers. And the domain is the x value. So that means, for example, in this graph, it'll go infinitely this way and infinitely that way. And the range is y. So that means our range can only be greater than 4 or equal to 4. So that means that this point onwards has to be greater than 4, right? And because it's greater than 4, it automatically tells us that our graph has to be facing up, meaning that we're going to have a minimum. So take a look. You can pause the video and figure out which of these graphs has a vertex of -2, 4, and which one has a range of y is equal greater or equal to 4. In this case, let's take a look at this one. Well, actually, let's start with this one first. This one has a vertex of 0, 0. And this one has a vertex of 0, 0 as well. This one here, let's check. Let's go 2 to the right and up 1, 2, 3, 4. Hey, that has a vertex of -2, 4. And then let's check the other piece of information. It definitely has an axis of symmetry of -2 right here. This is x equals -2. And the range says y has to be greater than 4. So that means it has to go this way. And it is. So for number 1, our answer is A. For number 2, it says that the graph is a vertical stretch by a factor of 3 of the graph of f of x is equal to x squared. So a vertical stretch is when you have a graph that looks skinnier than the original. And a vertical shrink is going to look wider than the original graph. But don't be tricked by how the graph just looks, right? Sometimes on a quiz or test or a homework question, it might try to trick you by showing a graph with a different scale, right? You can make a graph look wider or longer just by changing the scale. So make sure that when you're comparing graphs that the scale is consistent, right? Because the scale that is used can make a graph look wider or skinnier. All right, so let's take a look. What would really help with this one is to just make a table, right? So let's make an XY table here. Okay. So for this one, let's figure out what values we could put in here. And before we do that, if you have a vertical stretch by a factor of 3, what would your new equation look like? It will look like this, right? When you have a vertical stretch or shrink, it changes the a value. So that means it changes the one in the very front. So this would be your new equation. G of x is equal to 3x squared. And now we're going to plug in values in here to see what the points look like. So if we plug in 0 for x, what would we get? 0 squared is 0 times 3 is 0. So now we know our vertex. And now let's plug in 1. If we plug in 1, 1 squared is 1 times 3 is 3. That means we also know our second point. Let's plug in some more points. Let's plug in 2 now. 2 squared is 4. 4 times 3 is 12. So we have 4 points in here. And now, now that we have all 4 points, we can see which of these points corresponds with the graphs that we have left. So let's take a look at C. This graph is facing downwards. So, knowing that it's facing down, we know that it can't be f of x is equal to x squared. Because Or it also can't be g of x equals 3x squared, right? Because 3 is positive. If it was negative 3, then we might have been able to consider it, but it's positive 3. So that means it'll have to be facing upwards. So these are the only two options we have left. Let's see some points in here. So 0, 0. This one has a vertex of 0, 0 right here. So does this one. So let's see this. And the first point was 1, 3. So let's see if it has 1, 3 in here. 1, 2, 3. It does. Negative 1, 3. Yeah, it has that too. 2, 12. Yes, it has that as well. But you won't necessarily need to do this. In many cases, you'll be shown different graphs, and you can just tell by looking at it, right? So for this one, it has a scale of 0 to 5. So if you wanted to, you could draw a graph on top of it to see what just x squared looks like. But in this case, our answer is going to be B for 2. And now, let's try the third one. The graph is a vertical shrink by a factor of 1 over 3 of the graph of f of x equals x squared and a reflection in the x-axis. So similar to the first one. So now, instead, we have 1 over 3. Okay. So g of x is now equal to g of x is equal to 1/3 x squared. So that's our new function. And you can go ahead and try the same thing as well, right? Create a graph, x and y. We can go ahead and plug 0 in. If we plug in 0, we get 0 squared times 1 over 3 is 0. If we plug in 1, we get 1 squared is 1 times 1 over 3 is 1 over 3. And now you notice that it's a little difficult to work with fractions. It's kind of hard to plot them. So, since we know that there's a 3 in the denominator, if we multiply by something that will give us a numerator that's divisible by 3, it'll make our lives a little bit easier. Alright, let's try 3. 3 squared is 9. 9 times 1 over 3 is, or 9 divided by 3 is 3. So let's plug in 3. 9 divided by 3 is 3. So we get 3, 3. Alright, so this one, which of these graphs is opening downwards? Actually, I made a little mistake here. See if you can identify the mistake. It's a pretty good learning experience, actually. The mistake that I made here was that it says that it's a reflection in the x-axis. I did not account that in my equation. So when I have a reflection in the x-axis, that means that the a is going to have to be negative, right? For example, if this was reflected on across x-axis, it would look like this. Something like this. It would be facing downwards. So, to change it, we need to make the a a negative, negative 1 over 3. So now, that means that all of these would also be negative as well. So which of these has a graph that's facing downwards and fits this, right? It has to have 0, 0, it has to have 1, negative 1 over 3, and 3, negative 3. So it seems like this one might be our answer for now. So let's check it and make sure that it's correct. So it definitely looks like a vertical shrink, right? The graph is a little bit wider compared to this one. It's wider, and it is reflected across the x-axis, and we can identify the point 0, 0 right here, and we can find 3, negative 3. Let's try it out. 1, 2, 3, 1, 2, 3, right here. So that checks. And that's how you would solve that. And normally, just make sure that you check the scale before you do this one. And for vertical shrink, you want to find a graph that became wider And for a vertical stretch, you want to find a graph that became a little skinnier, depending on the scale that you're going by. So in this one, our A is 3, so that means it's going to be a little bit skinnier. Okay, and I hope that helps. Let me know if you have any questions. Good luck on your quiz, or I mean test, sorry.